Well, hello everyone. Welcome to this hopefully last part of this very long DLL injection into all processes tutorial. And today we will be conducting final tests of the final product. And without any further delay, let's go into our development environment and start an IDE. And let's make sure we do that and don't just say that. And inject all. This is our solution, and if you remember in the last video we actually created a limited build of the driver for the onload image where we injected only into Notepad. Now we did this on a 64-bit operating system, so what I suggest we do before we open it up for all processes without this limitation is that we will test it on a 32-bit system. So for that, let's build our driver. Let's do rebuild, and build succeeds. So at this point we also need to build a 32-bit fake DLL. Let's do rebuild. Now note that we don't need to rebuild 64-bit because obviously we can't use it on the 32-bit OS. And before, well actually no, not before, hold on, if we go in and inject all, so we will be dealing with only two files here. Now this one would be very simple. It's a driver.sys and fake 32DLL. So in this case, let's switch to our 32-bit development environment. Again, as you can see, I installed the same auxiliary apps that I was using before. And let's go into our inject all folder. And at this point, we need to copy and paste our driver. So let's do it as so. Okay, and then we also need to copy the DLL, fake 32 DLL. Let's copy it, and for now, let's copy it to the desktop. And at this point, we need to put it into the system folder, which is C Windows, System 32. And let's move it here. Okay, continue. And I need to provide my admin credentials. Okay, here we go. We got our DLL in the system folder. Okay, so now we need our driver loader unloader. We need to also run it as an admin. Okay, so this little app will allow us to start our driver and to register it. By the way, we don't need to do test signing on the 32-bit operating system because the Microsoft is not imposing it, so we can do without it. Okay, so at this point we need to run our debug view as administrator, and we have to agree to all the conditions here. So I'm going to put it here side by side, and what we need to do, we need to specify capture on pretty much everything. And as always, this thing continues to spam us here, so let's block it. What is it? Storm any. Okay, so that should remove it. Okay guys, so at this point we can actually register and start our driver. So it started fine, and let's run a notepad. I'm gonna pin it to the taskbar. And here you go. So we loaded OK. And let me see. Oh, for some reason we did not get our logging message here. So let's run process hacker. And let's see why. Where is our notepad? Okay, it won't tell us why, but let's see if fake DLL is actually loaded into it. And it is not. So something didn't work. So let's see what happened. Now, because our driver failed, now this is interesting. Why is it firing here? Okay, well, let's investigate. So we need to unregister our driver. Now, did I set up a crash dump folder? And I did not. So we need to do this. We need to run this war setup tool as administrator. And we need to go into C, new folder, crash dumps. Click OK. We'll set up an ACL for it. And we need full dump, and let's see, 10. Let's save it. And how about we clear this? Start a driver again. And run Notepad. It didn't crash. And let's see, we did create our section. But for some reason we did not inject into it. Well, let's take a look once again. Now the Notepad process. Now this is very weird. It keeps firing. Let's see, what if I start something else? Yeah, it tries to inject into everything. Now what did I copy here? Okay guys, I'm getting really confused. The problem is probably I didn't copy the right file. And sure enough, I copied the release. Well, that is pretty stupid. We obviously don't need release yet. So make sure that the driver is stopped, and it is. So let's copy the right file. What we need here is actually debugger driver 32. And let's copy it here. Okay guys, and what you were seeing pretty much was the previous build of the driver, where I didn't even finish coding it. So this is very important. So let me switch back and to take your file when you test it from the actual correct folder, okay? Because again, release wasn't even built yet at some intermediary stage. So kind of shows you that stuff happens. Okay, so let's do again. We have the same driver. And let's see, register and start, and it starts fine. Now let's run it. Okay, so now we get all of our debugging output, and what do you know? We actually got this debugging message here, a logging message. And let's run process hacker, not non-elevated. Okay, so 596 is the process ID, and as you can see, all of them are 596, which is good. And let's see if the fake DLL is actually in there. And it is. Look at that. So it worked. Let's close it. And let's start over. Now in this case, we should have not created a new DLL. And let's see. Yep, known DLL was created only once. Let's run it again. And let's see, Notepad 5524. And fake DLL was actually injected into it, which is nice. And we can look at the output, and the output is also correct. So at this point, we can tell that our driver is working on a 32-bit system as well, just for Notepad. Just to be sure, let me clear it and make sure that it doesn't fire up for everything. And it doesn't. Again, I ran calc here and it didn't do anything. And let's unregister it. So process hacker tells us that our service, well, it thinks it's a service, has been uninstalled. Very thankful for that. And let's see, let's remove this. And what we need to do, guys, we actually need to reboot because we ran the previous version of the driver 32 and it well, it started injecting it into everything, which is not okay. We don't know the state of the system, so let's quickly reboot. And I'm going to do restart, and I will come back when it finishes up. Okay guys, so I finished rebooting, and I spared you the fun of watching me do that, and basically restarted everything. So at this point, our system should be clear, and we can come back to it a little bit later. Okay, so let's go back to our development environment. And what we have achieved here, again, we need to go to debug. And what we have done here, we basically limited our driver. Well, let's wait for the IntelliSense to wake up. For some reason, in this latest version of Visual Studio, the IntelliSense really sucks. Come on. Okay, so let's deal with 64-bit. Okay, if you see, we have this preprocessor thing defined that basically says that, hey, limited only to notepad.exe, and we needed it for debugging builds so that we don't crash the system. Well, at this point, it seems like our injection actually is working, and we don't need this, right? So we will be injecting into all processes. And you know what, the verbose output is also quite a lot, because you know it really puts a lot of stuff into debug view, so we don't really need that as well. Okay, so that kind of creates a driver that will inject pretty much our fake DLL into all processes. And that's kind of like our target and our goal. At this point, I'm going to do debug clean solution. I will do this for all of them, by the way. And clean solution kind of like removes all the files that we had there before, all the builds. And let's do release clean solution and x64 build clean solution. Okay, and then we reverted back to debug. And let's take a look. So if we go into debug, there is nothing here. Into release, nothing here. x64 debug. Well, don't care about setup information, and release is also empty. So now we know that everything is clear. And what we need to do is do the same, but to rebuild everything. So debug x64. And let's do debug x86. And build rebuild solution. You can, I guess, use shortcuts, but it's easy for me to do it this way. And wait a second. There's always something, it's just, I swear. Okay. Variable is uninitialized. Why is it uninitialized? Oh, I'm sorry, it's initialized but never referenced. Well, let's see where we're using it. Really good thing is when we have the search in Visual Studio, we can actually see where it's being used, highlighted in orange. And sure enough, because we're not using verbose output here, it's not used. So what we can do is just do unreferenced parameter, put it here. The reason we got it is because we are treating warnings as errors, which is technically a good thing. Okay, let's start over. Let's rebuild it. You know what? I'm sorry, rebuild all for all everything, not just our driver. And let's see, okay, this is not an error. Okay, so then we go into release and we do rebuild solution. Again, we need to make sure that everything builds correctly. And then we go to x64, build rebuild solution. Okay, and that also builds fine. And then we go back to debug. Okay, so at this point we need to copy our, let's just do copy our DLL, which is release fake 64 DLL, and we copy it into our 64-bit operating system. So let's start from 64-bit, and we need to put this into C, Windows, System 32. because this is 64-bit DLL. I know that's confusing. You put it into System32 even though it's a 64-bit, but it's a legacy stuff. So it needs my credentials. So okay, we did that. Then let's do 32-bit DLL. And we go into release and fake 32 DLL. And it's in system wow 64. I know it's kind of opposite. This one is 64. And we were able to put it right here, which is correct. Okay, and then we need the driver itself. And we will be using a debug build because it has some output that we might need, and it's actually in x64 debug driver64.sys. So let's copy it and paste it over here into our inject all. Now I understand, guys, in normal circumstances you would go into local disk C users, let's see, system32, and then drivers, and put your driver in here. Well, first of all, it's too much steps here, plus just to copy it into this folder I will need admin permissions, so that's why I'm not doing it. But normally, and well, regularly, you would put it right here. So let's see, yeah, let's delete this thing. We don't really need it because right now we'll be injecting it into everything. And let's clear here, and at this point let's register and run and start a driver. Okay, so now, oh, you know what, hold on, let's unregister it. Forgot one setting. Obviously it's not start on demand. We will be starting it with the system. In other words, start it as early as possible so that we can do a reboot, because you know right now certain processes are running already and they don't have obviously our DLL, so we don't want to restart it. So the easiest way is just to again specify start type as system start, and again let's start over. Okay, started okay, and well, let's try Notepad. It started fine. Let's just tell calc, and well, something else is spamming us here, but you can tell that the background task host got injected, calculator.exe got injected, runtime broker got injected, and right here we have all those processes: DLL host, runtime broker, notepad. So well, at this point, let's make sure that inject all folder has the right security descriptor, and it does. If you go into advanced, it's integrity level, untrusted, mandatory level, so we should be able to write into it. Well, let's see if we clear the output, because again we'll be getting a lot of stuff into it, and let's start the web browser, and you see how many processes it actually runs. Okay, we don't need to reload anything. And let's make sure. Yep, sure enough, we got MSA Edge, all kinds of runtime brokers. It started a bunch of services, something installing here. Yeah, guys, the web browsers aren't easy these days, so it has a lot of processes here. Let's minimize this. Okay, well, guys, let's run. Not war setup. Oh, yeah, by the way, let's bring up the folder with crash dumps. And so far we don't have any. Let's make sure that they are set up. I'm running this war setup tool, and sure enough they are set up for C crash dumps. Okay, now if we run our process hacker as elevated. Okay, well, I should probably remember my credentials. And let's look into Edge, and let's see if it has our fake DLL. Go into modules, and let's see, do I see it? Yep, here we go, fake DLL. And let's see if it has any security mitigations. Okay, that's a light process, doesn't have anything. I'm looking at all, yeah, like this one, for instance. As you can see, it requires signature restricted Microsoft only. Well, let's see if we inject it into it. And Sure we did. Fake 64 DLL. Obviously, if you open file location here, it doesn't have any signatures and it's not signed by Microsoft, but still we were able to bypass this restriction here and pretty much anything else also. Okay, well, at this point, guys, the interesting test would be to restart the system and see what happens. So let me close this, let me delete this, and just go for a reboot. So let's watch. Technically, during the restart, the reboot, if there is a problem, we will get a blue screen of death right away. And if not, we will get pretty much everything with some minor exception. Every process on that system will have our fake DLL injected into it. So yeah, let's give it a second and let's see what happens. Technically boots really fast. Okay, so far so good. Let me provide my credentials here. Obviously, you know, probably slowed it down a little bit since we are writing into our file, into that log file, into C:, / inject all. So that obviously something that slows things down, but also this is an AD account with a roaming profile, so that might be slowing it down. Okay, well, let's see what we've got in our log file here. And 4 kilobytes. Yeah, look at that. Let's see, we can't even open it because we probably don't have permission for it. Let's see, did ACL change? At this point, probably one of the processes has opened it that was running as administrator. Let me try it this way. Or maybe one of the restricted processes. But let's see if that will help. So C, inject all. Okay, here we go. Yeah, that was the problem. As you can see, oh yeah, it was created from WinLogon, and that obviously, you know, it's a privileged process, so it probably put a security descriptor on it. And as you can see, all of these are the processes that we injected in so far. And so that's good. Let's open Process Hacker and let's see where are we. Now, obviously, we will not be in Session Manager because if you look at modules, it doesn't have kernel 32. So it didn't trigger our callback. In this case, we would have to catch NTDLL, but it means that we will have to basically call system services ourselves, which is a little bit more involved, and it's just one file, so that's not interesting. Now, this technically is not this memory compression is not a system process, and registry or interrupts are not. But let's see if we inject it into this one. And let's see, we did. As you can see, fake 64 DLL. And this is client-server runtime process, basically. And as you can see, it has all the restrictions. Again, it wants to be loading only Microsoft signed DLLs, but obviously this is not Microsoft signed. And well, let's see, WinINIT, another system process that is important, and we are in it as well. And if you look, it also has all kinds of restrictions here. Well, guys, I'm not going to go through all of them, but let's say something like Smart Screen. This is a UWP, I believe, and let's see modules, and we are in it as well. So here's the fake DLL. Let's see if we are in one of the service hosts, like this one, for instance. And we are here as well. Well, let's see. How about Microsoft anti-malware service? That's definitely restricted process. And guess what? We are in it as well. Fake 64 DLL. It has all kinds of restrictions, and again, that didn't help. So at this point, pretty much anything well, let's say OneDrive, I believe, is a 32-bit process, and it is. If you look into modules, oh my goodness, how many of them are in there? Did you see how long it took? Okay, yeah, in this case it's a 32-bit, so we have two versions of our DLL, 64-bit and 32-bit. Like I was explaining, basically 32-bit processes also have or can have 32-bit DLLs mapped into them, as long as they just, import from NTDLL and kernel 32. So we have two versions of them in here. And obviously Explorer, which should not surprise you because it doesn't really run with any restrictions or any high privileges, so we have our fake DLL in it as well. Okay, well guys, so here you go. Let's see also the crash dump, and so far nothing has crashed. And well, just like for the heck of it, let's like start, I don't know, command prompt. Didn't crash. And again, checking the module list obviously is not gonna, it's gonna be there, so it's not fun anymore. And let's see, let's start a web browser, the one that has a lot of restrictions, and let's minimize it here, and let's just check main process. And oh boy, there's so much stuff going on in there. Okay, we have fake 64 DLL. Just look at the number of modules that have been loaded into it. Oh my goodness, no wonder that thing is so slow. And let's see, that's not the restricted one. Let me just pick something at random. Okay, that's a restricted one. You see Microsoft signed only, all kinds of other security mitigations. Modules. Here's our fake DLL. So this kind of shows you that we can easily inject into all running processes, with some exception of system processes, which aren't really processes. And at this point, well, we need to stop our driver, because what it's doing, if you look at this file, it's growing in size, because we didn't put any recycling into it, so it will continue growing for as long as things are being started here. So let's stop the driver, and you can see it keeps giving us messages that something gets mapped. And let's unregister driver, and it did unregister. Now we still probably wouldn't be able to open it, because again the DLL is loaded into something here, probably logon UI. So now to get our system back, we have to restart it again. And in this case, because we stopped the driver, when the system reboots, it should release our DLL, our fake DLL, which should not be loaded into anything. So let me pause it, and I'll fire it up when the system boots up. Okay, so we just booted up, and let's go look at our log. So right now it should technically let us, I guess it still doesn't let us in. Let's see what's going on. It probably has, yeah, it has a security descriptor basically, which is very restrictive, because again, we created it from logon UI, and in our DLL we didn't change it, so that's why we can't open it. But that's fine. So if we go, well, let's just start process hacker and just like open any user mode process, like let's see, Explorer, and it's sorted, and let's see, fake DLL is not there, as you can see. This means that our driver has been unloaded. And yeah, so at this point it just shows proof of concept that it works on 64-bit operating system. And the last thing to do, let's try to test it on 32-bit system. Now I think we built everything. To be honest with you, I don't remember. Let me just do it just in case. All we need is just a x86 and release and debug. Let's rebuild it as well. Now luckily it builds pretty fast, so we don't have to really wait for too long. Okay, so in this case we go into debug and take our debug version of our driver. Right, so and go into 32-bit system. Let's copy it here. It's actually a little bit smaller. And also, we need to get our DLL, which is release, and fake 32. Now this part is very tedious, guys, and very error prone, like I showed you. So this goes into C, Windows, user 32. And let's paste it. Yes, please replace it. Okay, so let's move the driver here. And we need to start it. We need to start it with the system. Register and start the driver. Let's make sure that it works. Okay, MS Paint, actually Smart Screen actually was first, as you can see. And let's do, like, I don't know, Calc. And let's look at the log, and sure enough, so again, there's like a lot of stuff that ran. And the reason you don't see Calc here is because the Calc is actually a UDP app, so it was started by either this thing or the runtime broker. And well, like before, let's reboot. So again, at this point, we need to see the boot process and see, you know, basically if it blue screens. At this point, it means that our driver probably has caused it, unless you installed something else, which I would definitely not recommend, because, you know, obviously otherwise you will spoil your test here. But let's see how quickly this one boots. And again, because this is a roaming profile on Active Directory, it's a little bit slower since it has to bring in all of my account settings. But this is relatively fast. So let's run process hacker as administrator. Okay, so let's check this process, system process, and we have fake 32. And it has all kinds of restrictions here. As you see, signature restricted Microsoft only. Obviously, our file is not signed by Microsoft. Well, I've gone through this already on the 64-bit system, but this one, let me just pick a couple processes, fake 32 DLL, some service host. Now let me just try, let's see, Microsoft, what is it called? Anti-malware service. And let's see, fake 32 DLL. Obviously has a lot of restrictions here. And let's try Explorer. Explorer doesn't have a lot of security mitigations, but let's see, it has a lot of modules, and we have our fake 32 DLL in here as well. And let's just start the web browser just to ensure that it can load up. And here you go, it works. Let me minimize it and check. Well, let's just pick something and see if it's in there. Here we go, fake 32 DLL. And let's go and check our crash dump folder. Nothing. Let's make sure that we set it up. Let's start worst setup, and it is set up, as you can see, for full dumps. Crash dumps in C folder. So at this point, this means that our driver is working. And just for the heck of it, let's just pick something at random. You see, it's here, and let's say this one. Let me try like LSAS, and that's the kind of like favorite process for people to hack. And it has fake 32 DLL. Obviously, it probably has a lot of, that doesn't have a lot of restrictions. Okay, guys, I'm not going to go through all of them, but you can try if you want to. So lastly, let me stop this thing. Again, don't let it run by itself, because this file will be growing quite uncontrollably, because every time you run a process, the driver, I mean the DLL, the fake DLL, will add an entry here. So let me run driver loader unloader. And what we need to do is to put service here and unregistered driver. Okay, so service has been deleted. Nice. And what we need to do at this point, well, I guess delete this thing and reboot. So at this point, that concludes our testing of our project. As you can see, there is a lot that went into it. It literally took 16 videos to actually, show all this stuff, but I kind of went very, low level and very deep into this process, kind of tried to show pretty much everything. Now, it's possible that I misspoke in several places or maybe mistyped certain things. It's also possible that there are some bugs, because this is like literally the first build of the project that we tried. And since it booted up so quickly, let me make sure that our fake DLL is not injected. Let me just look and find Explorer. And let's see, it's sorted alphabetically, and let's go to D, E, F, and it is not injected, so that's nice. And let's double check one last time that there is no crashes in the crash dumps folder, and there is no log. It means that our DLL is not creating any logs. Okay, well, so I will try to upload this solution to GitHub. I will also try to make a blog post so that you guys can have some basic information. Now, obviously, I'm not going to lay out everything in text because it's going to be a very long one. And yeah, so I will do all that stuff. Okay, guys. Well, at this point, I will stop this, and that was final testing. Let me see if there is something else that I find in this project, and if so, I will record a follow-up. Otherwise, thank you for sticking with us, and I hope you didn't start watching just from this last part. Please make sure to check all parts before it. I know it's pretty long, and not sure if anyone is even interested in this. And if you are, I can record something like this again, maybe not as long as this driver project, but I think it was kind of interesting. It was definitely confusing because, typing and coding at the same time and talking and coding at the same time is not the easiest thing to do. But at this point, thank you very much for watching, and I'll see you next time.